Audio recording for this meeting has begun.
Good afternoon, everyone. My name is Molly Marin. I am the webinar coordinator for the New York State RTI Technical Assistance Center. Just a few reminders. We have a copy of today's PowerPoint available on our webpage. There'll also be one additional handout that I'm going to post to the webpage in just a few minutes if you want to watch for that. That will be referenced in today's presentation, so it'll be out there for you to download. At the end of today's presentation, I will post a link to an evaluation. You will also receive that via email. If you could please take a few minutes to complete that, we very much appreciate the feedback. We do look at all of those responses every week. Also, throughout today's presentation, feel free to use the chat box for any questions or comments that you may have. And Tricia, I already grabbed your question, so you don't feel like you have to retype it or that it's lost. I have it for you. Today's topic, or today is the third webinar in our database decision making in an RTI process strand. Our last webinar in this strand will take place on January 12th, so we'll have a little bit of a break, but we hope you can come back and join us on the 12th. And more information and registration information can be found on our webpage. We are very pleased to have back with us again today Dr. Edward Shapiro. Dr. Shapiro is currently Professor of School Psychology and Director for the Center for Promoting Research to Practice in the College of Education at Lehigh University, Bethlehem, Pennsylvania. He is the 2006 winner of the Senior Scientist Award given by the Division of School Psychology of the American Psychological Association in recognition of senior member of the field who has provided a sustained program of outstanding theoretical research. He is author, co-author, and co-editor of 16 books, including his most recently published text with Joseph Kowalski and Amanda Vanderheyden, The RTI Approach to Evaluating Learning Disabilities. Dr. Shapiro is best known for his work in curriculum-based assessment and methods for assessing and intervening in academic skills problems with elementary-age students. Among his many projects, Dr. Shapiro recently received his second U.S. Department of Education training grant to train school psychologists as facilitators of RTI processes. Over the past decade, Dr. Shapiro has been working as a consultant with the Pennsylvania Department of Education to facilitate the implementation of the response to intervention methodology for the state. At this time, I would like to welcome back Dr. Shapiro.
Thanks a lot, Molly, and good day to everybody. Looking forward to hopefully another exciting hour and a half here of going through more of the processes related to database decision making. I did get Tricia's question, and I will respond to that. And I also wanted to just respond. Last week, one of the folks had asked me something about iReady and asked a question about that product, which I had a chance to check out this week. And it looks to me like it's a very effective and probably very valuable computer-assisted or computer-adapted test, similar to the other ones I mentioned last week. And I see no reason why that one wouldn't be as effectively used as any of the others. And Tricia, I will get to your questions as we go, but certainly I will make sure that I respond to them as we get towards the Q&A portion today. So today's session is a little bit more technical and a little bit more complicated in terms of what I'm going to try to get through to everyone and explain to everybody. And there is one handout that you might want to think about potentially printing out if you have the capacity for a printer or you have a large enough monitor you could keep it on the side. And Molly's going to make that available. It's a file called Gap Analysis, and it's a worked example of something that I'm going to take you through today. And it might be helpful to have that sitting aside. And if not, you'll be able to print that out later and follow it through, and I'll certainly be able to address questions about that one at our next webinar in January. I'm going to be really talking quite a bit today about the concept of rate of improvement and how we use the concepts of rate of improvement in how it's calculated, but more importantly, how we use that concept in conducting what's called a gap analysis. And the gap analysis is a critical element in the process of really identifying and using RTI processes for identifying students as potentially having a learning disability and qualifying for the category of specific learning disability. And I'm going to be talking about the rate of improvement for both progress monitoring and benchmark assessment. and we'll be talking some about how do we interpret progress monitoring data at the end of the webinar. So we have a lot to cover, and I'm going to try to walk slowly and speak clearly and slowly and walk stepwise through the process so folks can understand it. Let me start by mentioning first that the CBM, curriculum-based measurement, which I know you're all very familiar with, has many, many strengths, in particular for progress monitoring. We know that it's a measure that's relatively short in its duration to give. So it usually can take as short as 1 minute, or that's for reading. If you're using it for math, it can take up to 8 minutes in math. That's usually group administered. But in any case, the progress monitoring, use of CBM for progress monitoring is a very efficient and a very time-efficient kind of process. And we know that in reading in particular, it's a general outcome measure, and what that means is that the measure cuts across reading skills and has very strong correlation to state assessment. This is particularly true, as we know, up through about 3rd grade. Beyond 3rd grade, the measure begins to wane a little bit in its predictability, but it certainly is a strong measure that's well used and well regarded as a progress monitoring measure. And we know that the measure will remain very sensitive to growth within the grades across the year, so that we can use the measure to monitor how students are growing based on our instructional strategies and interventions over the course of a year. One of the things, however, that's really important to know is that CBM is not the only measure one can use for progress monitoring. In the RTI world and the RTI processes we use, the measures we use for progress monitoring have to meet certain requirements, in that they have to be repeatable over short periods of time. They have to be sensitive to growth based on instructional intervention, and they have to be able to be used in calculation of rate of improvement. So they have to have some kind of a normative base to give us a starting point and an ending point for those measures. But honestly, CBM is not the only measure that can be used. And if you're using a computer-adapted test, I know in New York I came across at least some school districts that are using measures like STAR assessment from Renaissance Learning, or this iReady product that I heard about last week, and I'm sure there's others. Those are all usable as long as they meet those requirements for progress monitoring. So why is rate of improvement, ROI, so important? Well, clearly we know that what RTI is about, and RTI is based on, is the capacity to identify whether a student responds or does not respond to instruction and intervention. What's critical then is that the assumption we always have to make is that the fidelity of core instruction and the fidelity of the intervention is strong. We cannot do good RTI unless we have really strong core instruction and really good and strong fidelity with interventions. If those things fail us, then we don't really have much to talk about with RTI. Assuming we have good fidelity, and we have good fidelity of both core instruction and intervention, then we have to calculate a student's rate of response to this instruction, and we have to do that against 2 key items that we think about. And the easiest way to think about these are 2 simple terms that we sort of boil the RTI model down to, and is how low is the student and how slow is the student against peer expectations. So ROI, rate of improvement, is used in the areas of both talking about how low and how slow a student is. Let's talk about first the question of how low. So how low a student is essentially related to the difference that a student has between their peers in terms of reaching expected benchmark scores. Benchmark scores, I think, as you know, these are the cut scores. These are scores that are empirically derived, and they represent essentially the minimum score a student should achieve to reach proficiency. Now, I emphasize this, the minimum score that a student should reach to achieve proficiency. What we really want is we want students to exceed those minimums and to do better than those minimum benchmark scores. And that's really our objective and our goal, to get as many students as we can above those minimum benchmarks. But we use those minimum benchmarks critically to mark the values that represent what we would consider to be proficiency or the lowest acceptable level of performance on our measurement tools we're using. One of the important questions that arises is whether we should be using national or local benchmarks. And this is a more complicated question than it seems. Clearly, when you're thinking about the benchmarks that students should achieve, we should probably first be thinking about national benchmarks. We want to make sure that our students are measured up against what the national normative processes and data are telling us these students should achieve. We could also, of course, be talking about our state benchmarks in terms of our core standards and the degree to which our students are meeting our state standards or the Common Core standards if those are the ones that your state are applying. The issue, however, also comes up about local benchmarks. Should we be talking about the local benchmark that the student is achieving? The problem with local benchmarks alone is that the local benchmarks could be very deceiving into determining how a student is doing. And that is, if I'm in a school district or in a school building that as a school is achieving at a much lower level than what would be expected at the national level, then clearly a student who looks average in that school would be potentially not average against the national standard. Likewise, a student, if you're in a school that's achieving at a very high level, and I'm using local benchmarks, I could have a situation where I have a student that looks very much below average, but when I look at national levels, they're very average. So I think the key here is that one has to look at benchmarks in a variety of ways. I tend to prefer a national and a state level benchmark over local benchmarks. But the local benchmarks do provide information that can also help us in understanding and contextualizing the nature of the problem we have. We also look at local benchmarks in a situation where, if we have a situation where the local benchmarks are showing us a school that is really underperforming the national level, then our problem is much bigger than individual students. It goes to the level of, can we increase at the core instruction level the need of that school or the potential of that school to reach some higher levels of proficiency. But we're going to be talking today predominantly more about the national level of benchmarks as we talk through this process. The question of how slow or how low is a question of level, how slow is a question of growth. And here we're talking about how much has a student grown over the course of time, and we're going to be talking about that first in terms of benchmark performance. And here we're going to be talking about specifically how a student grows against those students who would be starting at the benchmark level and ending at benchmark level by the end of the year. Let me introduce you to a key resource that I'm going to show you the website for. This is a site that has been developed by a couple of I believe they're school psychologists, and these individual folks have put together a very, very exciting site called Rate of Improvement. And I'm not going to go through the site for you, but you have the URL there. And it provides some tremendous resources about the calculation of rate of improvement and some tools for doing it, and just a wonderful, wonderful resource that you might find valuable as a supplement for the work that you're doing. So I would strongly urge you to take a look at that and check it out when you get a chance. Let me go back to... Let me get back here. Okay. Molly, we can move the share my screen to the side. Thank you. But this is a great resource that you might want to check out when you get a chance. It's a really good set of tools. So let's start with the question of how slow. And throughout the presentation today, throughout the webinar, I'm going to use grade 2 and do a worked example of a grade 2 student. Now this same example is relevant for all the grades we work in, and it's relevant for any of the benchmark tools that we use where we have data across the year. This works very well when we have the same measure taken at all points in time. If you're working, for example, at kindergarten or first grade and you're working with measures that only are done at the beginning of the fall and the middle of the year, then you have to make some modifications on this process because the rate of improvement wouldn't be calculated across the year. It might be only calculated on the fall to winter period. But I'm going to be talking about a grade 2 student, and I'm going to be talking about across the year the same measure that's being given. So there is some variation when you don't use the same measure across the entire year. So the question of how slow is, we're going to be asking this question in two ways. We're going to be asking the question today about how slow is a student compared to the student for their benchmark scores, and how slow is that student for progress monitoring. So we're going to be looking at the question of how slow in two different ways. Let's start with how low. And how low is a fairly simple question. So here we have a student who is a second grader, and I'm using the DIBELS Next benchmarks, and I'm using oral reading fluency, so these are words correct per minute. And you know from the DIBELS benchmarks that in the fall, that student's benchmark would be 52, 72 at mid-year, and 87 by the end of the year. Here comes our target student. And our target student has a score of 20 in the fall and a score of 50 at the end of the year. So the question of how low the student is very simple. What is the distance and difference between the student's score at fall benchmark and then at spring benchmark? And we're going to talk about the calculation of that in something called a gap analysis shortly. When we draw the line between these 2 points, of course, that represents where we would have expected the student to go in terms of growth, starting at 20 and ending at 50. When we talk about rate of improvement then, we're talking about the change over time, we talk about rate of improvement and we talk about 3 key terms that I will use over and over again as I go through the webinar. The 3 terms involve typical rate of improvement, targeted rate of improvement, and attained rate of improvement. The typical rate of improvement is the expected rate of progress that a student would make if they started at the benchmark in the fall and kept at benchmark in the winter and ended at benchmark in the spring. That's called the expected rate of improvement, or the typical rate of improvement, expected rate of progress. The targeted rate of improvement is the rate of improvement from the starting point of the student who is below the benchmark to the next benchmark point. And in our case, an example, we're going to use the end of the year as our targeted data point. The attained rate of improvement is the actual rate of improvement, or the slope or the growth attained by the students. And it can be in progress monitoring or it can be in benchmark assessment. So let's do some calculations on the data that we're going to be working with today. So, and there's a graphic of this that will come up here to illustrate it as well. So let me show it, to walk you through here, show you the graphic again to be redundant a bit, but to make sure that you understand how this is calculated. So the typical rate of improvement is a student starts at 52 in the fall and ends at 87 across 36 weeks. And very simply, it's 87 minus 52 divided by 36, and it's 0.97 words correct per minute per week. That's the rate of improvement of a student who starts at benchmark in the fall and ends at benchmark in the spring. That's what we would have expected of the typical performing students using the DIBELS Next normative data set. The target ROI is based on our target student. Now, if you remember here, our target student started at 20, ends at 50. So what we're doing here is we're starting at the student's level of performance, 20, ending at the benchmark score, 87, expected for second grade, in 36 weeks, or a rate of improvement of 1.86 words correct per minute per week. The attained rate of improvement is what the student actually did. They started at 20 and ended at 50. So their actual rate of improvement was 0.83 words correct per minute per week. So this student was moving at that rate over the 36 weeks. These kinds of calculations can be used by looking at any of the measures that are out there that do some kind of that have a change over time. DIBELS Next and AIMSweb are both two that are very common in the CBM area. So here's an example of a DIBELS Next rate of improvement across grades for different measures. You will notice, for example, that measures like PSF that are not given really in the fall of kindergarten, but given winter and spring, this measure is looked at from 0 to 40 over 36 weeks. Nonsense word fluency, likewise, starts at 0, ends at 28, because it's not really even given at this point in time. A measure like oral reading fluency, which is also not given in the fall on DIBELS, we started at 0 point, just as a baseline. Again, that rate would be 1.31. So this gives you a little indication of across the 36-week period what the rate of improvement is, and what it is on the fall to winter, and winter to spring if you're interested in that. Here it is for AIMSweb. This is an example that comes from the AIMSweb database, and this is calculated in the same way. AIMSweb gives you a nice little tool in that they break down the performance by percentile. So you can see at the 50th percentile what the rate of improvement is for a second grader, and you can see what it is for the 25th percentile and what it is for the 90th percentile, and that's broken down for each grade level. Calculated the same way. Spring score minus the fall score divided by 36. So here are the data graphically that I just described. So here we have our benchmark for the student, starts at 52, ends at 87, typical rate of improvement, typical benchmark, 0.97. Here's our target student at 20, ends at 50. That student has an attained rate of improvement of 0.83 words correct per minute per week. The targeted rate of improvement, which is the change from 20 to 87, this would mean this is the line, this is the rate of gain a student would have to make to stay on target and close the gap between themselves and the rate that they're on and their peers. And that's 1.86 words correct per minute per week. We have our differences in benchmark at fall and our differences at benchmark spring, and that'll become more important shortly when we go into our gap analysis calculations. So, let's talk a little bit more about benchmark rate of improvement interpretation and the gap analysis. A student, in order to close the gap between themselves and their peers, in order to close this gap, they have to move at a rate faster than a typical student's rate to close the gap. And that was what we talked about last week when we were doing goal calculation for the entire group. This student, this particular student here, is actually moving at a rate, 0.83, is moving at a rate about 20% slower than a typical student's rate. And what you can see is that the gap between this student and what is expected has actually gotten larger rather than smaller, which would suggest that that student is not responding to the instruction in the way that we would have hoped to see. These values become really critical in this calculation, and they really help us define what's happening in a quantitative way to that student's performance. A gap analysis is very simply a quantitative way to describe this relationship and answer the question of how low and how slow a student is. It is very simply the discrepancy between the expected value that a student should achieving, and the attained performance. And we translate it into an empirical value, and we simply do that by dividing the performance at the point of referral to the expected benchmark performance of similar age and grade peers. And I'm going to take you through this calculation here in just a second. What I want you to understand here in this little diagram is the following. If we take a student's expected level of performance and we divide by their attained level of performance, and those two values are equal, the result would be a value of 1. And a 1 would indicate that they're not discrepant from what's expected. As the expected value is larger than the attained value, this ratio will increase above the value of 1.0. At some point along this continuum, we cross a critical value. There's some point in this continuum at which the difference between what's expected and what's attained has become large enough that we as a multidisciplinary team begin to question whether we are approaching an SLD determination. What is that critical value that we cross? I've been asked that a million times when I present this. The answer is we don't have a critical value. There is no value that we can identify. The critical value is simply a representation of some point when the team begins to say that the difference has gotten large enough that we cannot see catch-up growth really happening here for this student. And that the value is large enough that we now believe we should be moving towards a more intensive level of instructional need that is one that has a specific learning disability determination. I'll share a little bit more of some guidelines in this process a little later in the presentation, but it's an important concept to understand what we're going to be doing in this gap analysis calculation that we're about to start. So for the calculation, I'm going to be using a grade 3 calculation. It's going to be grade 3 scores. So the calculated values, the values here now are grade 3. The DIBELS benchmark for grade 3 are the following. Fall is 70, winter 86, and spring is 100. Words correct per minute. Our targeted student that we have who we're going to be focusing on has started at a score of 40 and ends at a score of 71. So the first thing we need to do is we're going to calculate their typical ROI, their target ROI, and their attained ROI. And that calculation is a very simple calculation, not complicated. The typical ROI is we take the score in spring, we subtract the score in fall, and we divide by the number of weeks, in this case a full school year, 36, and we end up with 0.83 as our words correct per minute per week score. When we do our targeted ROI, we start with 100, which is where we hope the student will end up. We then subtract from that their starting point, and we then divide by 36, and we have 1.67 words correct per minute per week. Finally, the attained ROI. The attained ROI starts by looking at the fall to spring, which is the score the student ended up with, which was 71, minus 40, where they started, divide by 36, their attained ROI is 0.86 words correct per minute per week. So we look at this and we have an interesting phenomenon going on here. This student is moving at a slightly higher rate than their peers are moving at. So their rate of gain is actually about the same as their peers. However, they are not closing the gap between themselves and their peers. In a sense, they're moving on parallel tracks. And here's how it looks graphically. So here's our typical benchmark student, fall to spring, 0.83. Here is our attained target. This is our attained benchmark, our target student, starting at 40, ending at 71, 0.86. You can see these two lines are fairly parallel. Here is, unfortunately, the target that we would like our student to be on if they were responding well at 1.67. So we're going to do a gap analysis of this student's performance here. This is a worksheet that provides the calculation and the formula for each of these. And we calculate this discrepancy or this difference, this gap, using two different approaches. Excuse me, both of which are meaningful in interpreting the outcomes. So, first of all, we talk about a discrepancy, or a how low is the student. And in this case, it says winter data, excuse that, but we're going to use essentially the analysis that I'm calculating here is going to be at the end of the year. It says winter, it should say spring, but so just change that to spring on your notes. And I'm going to calculate that very simply. I divide their benchmark score by the attained score. So the benchmark score is 100. I divide that by their attained score, 71, and I get a value, 1.41. This represents, as you'll see in the interpretation, the discrepancy between the student and what would be, if they were at 100, a score of 1. Remember how I said this value that we get, the larger it gets, the more we're getting towards an SLD determination. So a value of 1, if we had 100 divided by 100, that was what they had attained, their value would be 1 and they would be non-discrepant. Unfortunately, in this case, the student's score was 1.41. An interesting question that we might ask is, so what percentage of the expected performance did that represent? What percent of expected performance? And this is a very interesting and simple calculation here. So we take 100, we subtract from that 100 minus 71, divide by 100, and we multiply by 100 to make the percentage, and we come out with 71%. So what that means is this student is achieving only 71% of what would be expected of a typical performing student by the end of that school year. That's the how low question, and a gap analysis for how low. We're converting these numbers into a simple quantitative way that gives us a value that becomes meaningful for how we can describe how a student is performing. Now let's go to the question of how slow. So the question of how slow, first of all, in benchmark, is against, first of all, against the target. So this is about how the students did, how much their performance across the year did against targeted rate of improvement. So here we take the targeted rate of improvement and we divide by the attained rate of improvement. Well, the targeted rate of improvement, which we had calculated here, was 1.67. We divide by the attained rate of improvement, which was 0.86, and we get a value of 1.94. Again, this value, if they had achieved an attained rate of improvement equal to their targeted rate, this value would be 1. If this value is 1, they're not discrepant. The higher this value is, the more discrepant they are from essentially meeting the target. What percentage of that growth was that? What was their percentage of targeted growth? Again, calculated this way. You plug the numbers in, and up comes a value of 51.5%. So that says that in terms of closing the gap, they were actually essentially falling behind by 51.5%. They only moved at about half the rate of what we would have expected them to move if they were going to close the gap. A second part of the how slow question is the discrepancy from typical. Because remember, as I said, a student could be moving parallel to a typical student. In this case, this is what was happening. So in this case, we divide typical by attained ROI, and gee, we get a value less than 1. Well, that's interesting. If their attained rate matched their typical rate, this value would be 1. If they're attaining a rate greater than the typical rate, it would be less than 1. And indeed, in this case, it was 0.97, which meant they were actually moving a little bit faster than a typical performing student. Not probably substantially or significantly, but a little faster. When we convert that to the percentage of typical growth, we would say this student is making 103.6% of typical growth. So, what do all these numbers mean in terms of interpretation? Let me work through the interpretation of this first example. So first of all, how low is the student? Well, against their expected grade level performance, the expected performance at the benchmark at the end of the school year, they were performing at a rate, or at a level, if you will, that was 1.4 times under expectations, or 71% of the performance expected by grade level peers. How about their growth? Because we always have to talk about both how low and how slow. Well, against the targeted growth, which is catch-up growth, against the catch-up growth, over the year, to close the gap against grade level peers, they remained 1.94 times behind their expected growth rate, or made only 51.5% of the expected growth. That's a problem if we're talking about a student who's responding or not responding to interventions. How slow were they against actual growth? Well, interestingly, against typical grade level peers, they grew at a rate slightly faster, or at 103.6% of typical performing peers. So the conclusion here is that although the student is growing at a good pace for third graders, that should say third graders, my error, his catch-up growth remains substantially behind what would be desired. Again, although their student is growing at a good pace for third graders, his catch-up growth remains substantially behind what would be desired. So, going back to this gap analysis concept, remember, a score of 1.0 is not discrepant. A score above that represents some level of discrepancy against what would be expected. The higher the value, the more we move toward an SLD determination process. This is an interesting heuristic that a school district here in Pennsylvania uses to help define for themselves these kinds of data and their interpretation. If you look at this example, in this example, they establish first what would be the expected level of growth that they would think would represent at least a student who is reaching or achieving a level of performance that the school district feels and the multidisciplinary team feel are acceptable. Now, this is not a state-level kind of analysis. This is a local analysis. But in this particular district, it looks like 80% or less of expected growth is viewed as very problematic. This is a district that expects students to make at least 80% of growth or better, or they're going to be viewed as probably needing far more instructional intervention. That's matched then against the level of intervention. In this particular district, they have different levels or tiers, of course, of intervention, Tier 1, Tier 2, and Tier 3. So for a student who is making 81 to 95% of expected growth, but has already been in Tier 3 for some period of time, that student falls into this consider NDE category. Whereas a student who might be making 81 or 95% of growth, but maybe a Tier 2, they would be viewed as possibly a Tier 2 student. However, a student who's making less than 80% of growth begins to fork towards maybe they need a more intensive intervention, or if they're already a Tier 3, now we have an NDE consideration. So it's a simple heuristic that this one district uses. I'm not recommending that you necessarily use this, but it's a way to think about how to interpret the outcomes that we get of these kinds of data. Let me shift my conversation now from talking about benchmark rate of improvement to progress monitoring. Now, we know that progress monitoring, of course, is a very key part of the decision in RTI. And we know that we use progress monitoring for many, many things, including decisions around the need to continue tiered instruction, to increase goals, or to change instruction. And we know that progress monitoring data are also going to be factored in as a potential consideration down the road for eligibility decisions. Excuse me. One of the very important aspects of progress monitoring that we have to remember is that many times when students are functioning at instructional levels that are far below grade levels, progress monitoring might be done at below grade level kinds of ways. So you have a fourth grader whose instructional level is a second grade level in reading, and you may decide to do your progress monitoring at second grade level, which is appropriate because there you're going to decide if the instructional level you're providing at second grade level instruction is really working, if that kind of intervention is effective, so you would be doing monitoring at that level. You may also periodically be monitoring the student at their grade level as well, but the bottom line in any SLD determination question is how are they doing against grade level expectations. So when you're looking at calculating rate of improvement kinds of values, you need to be thinking about rate of improvement values against grade level performance, not necessarily at instructional level kinds of performance. The key terms in doing rate of improvement calculations for progress monitoring are the same as they were for benchmark rate of improvement. However, the attained rate is calculated a little differently, which I will then talk about. So we have typical rate of improvement. This is exactly as it was before. This is the rate of progress of students from benchmark to benchmark. And because our benchmark students are not typically going to be progress monitored, we use the typical rate of improvement that we would use for benchmark ROI as our calculation for progress monitoring ROI. The targeted rate of improvement goes from the starting point of the target student's performance to the next benchmark point for that student. So we do that very similarly to how we did, the same way we did the benchmark ROI. The attained rate of improvement is the actual rate of improvement by the student in the progress monitoring process, and there are multiple ways of doing this calculation. There are three main ways in which we calculate rate of improvement for progress monitoring. One is called a 2-point rate of improvement, a modified 2-point rate of improvement, and the use of an ordinary least squares calculation. So the 2-point ROI calculation is similar to the benchmark ROI in that we use the starting and ending points of the data set. and we divide by the number of weeks across the progress monitoring that's being collected. Here we've got the starting point is 37, the ending point was 92, the ROI for that period of time is 1.53. If you want a little tool to use that, this link here, the Iris Vanderbilt Slope Calculator, will take you to a particular website where you can actually put those values in and do the calculation. I'm not going to go there, Molly, here to save some time, but it's just very simple. It just subtracts the two numbers, divides by the total number of weeks. Here's something that looks at graphically. So here's a student that started at 37, ended over here at 92, I believe it was, right? 92, or end of year, 92. We do the calculation, it's 1.53. That's actually this dotted line right here. So the advantage of a two-point calculation should be obvious. It's very simple to calculate it. And you could use the slope calculator as well, and it's very easy to understand. But here are some real problems with it. It's very vulnerable to single outliers, as I'm going to show you shortly. For example, if the last data point in this series was 60 instead of 92, the ROI would be 0.7. So if this last data point, instead of being 90, was 60, this would be the actual rate of progress, this red line. Look how much different it is from the dotted line. Maybe there's an end of school year drop. So we tested at the end of the school year and motivation for reading was much lower and the student did poor performance, but it would really affect how our outcome of our value that we calculated as rate of improvement. If the first data point was 60 instead of 37, likewise, the value would be very different again. Look at it here. It would be a very different value. Maybe we were getting, essentially, a beginning of the school year motivation. The problem with this value is that it doesn't account for the entire data set, and simply one or two outliers can really make it a very different value, which is why you may prefer a more precise method when you're when using these data for high-stakes kind of decision-making. A second kind of approach is called a modified two-point solution, and in this case we use the median or the middle score of the first three data points of the series, the median or middle score of the last three data points, and we calculate the value of ROI between those 2 points. So in this case, the first three value points, median is 60, the last three is 80, and the calculated value is 0.6. So as you can see here, the first three values, median is 60. Notice the student took a big jump between September and October. The median of the last three data points is 80. Notice that student took a dip between 59 and 92, between April and May. We essentially calculate and connect 60 to 80, and it's the red line here, and we see a different kind of value. The advantage here is that it controls for these outliers at the beginning and end of the year, and it's very simple to calculate. We could use a slope calculator since it's only 2 data points. It's not complicated. But it doesn't take into account the entire set of data. And again, because of that, we might prefer a more precise methodology for data decision making. Which leads me to the methodology that's essentially considered best practice and typically used in most of these calculations. This is known as an ordinary least squares calculation, or the linear regression of the data set. It's a mathematical process that essentially establishes the straight line that cuts through all the data points, and it's a mathematical calculation that one should leave the Excel spreadsheet to do, or a commercial software. DIBELS gives you the ability to do this, and AimsWeb actually calculates this in their output. But I'm going to illustrate for you this calculation in a second, but you have to understand something about it. I'm going to illustrate it with an Excel spreadsheet. And when you get these data on an Excel spreadsheet, the way you get that value, it shows up as essentially an equation. y equals bx plus a. It's the b value that represents the slope. And I'm going to illustrate that for you. And the rate of improvement website shows the same kind of element again. So I'm going to end up showing you a spreadsheet in which we do this. Molly, I'm going to share my screen here. So here's a data set that's produced in Excel, and it's the same data set we've been looking at so far. And I'm going to show you very simply how to do and how to calculate and get this line known as the ordinary least squares line, or essentially the trend. And if you click on layout in Excel, and you may have a slightly different version of it, but they're all about the same, you need to find the one that says trend line. And under trend line, you want to look at options, and I'm going to set the equation on the chart and close, and it just calculated a trend line here. And you can see this trend line has this y equals bx plus a, and it's this value, 1.0043, that represents the rate of improvement or the slope of this line. Very simple to do, easy to do with Excel, simple to do. If you need a little work with Excel, get someone to help you, but very, very simple. This is the trend that represents all of the data points averaged across this period of time. Okay, I'm going to go back to the, let's go back to the PowerPoint. So the attained rate of improvement for this student was 1.0 words correct per minute per week. The targeted rate of improvement, if you remember, was 1.47 words correct per minute per week. So let's compare the calculations, the different ways of doing calculations. Typical ROI was 1.28, targeted ROI was 1.47. Those are the same. But in the attained, look at the differences here. 2-point calculation 1.53, modified 2.0.56, OLS 1.00. Very, very, very different values. The recommended approach in the literature is to use the ordinary least squares, or to use a calculation that represents the entire data set over others. That's the best practice methodology, and the one that I would suggest that you use in doing this calculation. It's the one that you will find that AimsWeb does on their data set that they output, and I believe DIBELS Next has this available, or will have it available to you. I know you can calculate it by downloading their data and placing it into an Excel spreadsheet. So let's interpret the progress monitoring data a little bit. One of the issues with progress monitoring data that always comes up is how many data points do you need for a reliable trend? And it's really interesting here. There's been quite a bit of research on this that's come recently. I've always heard that we need, 4 out of 6 data points in the same direction, or we need at least 3 data points or 4 data points for a trend. What the research is telling us is essentially the more data points we have, the more stable is the trend. Ted Christ from the University of Minnesota and some of his colleagues have done some extensive work on this, and they've really found that the number of data points that you really need for a stable trend for progress monitoring data in reading performance, specifically oral reading performance, really is somewhere in the neighborhood of around about 10. This chart is really interesting. What this chart shows is, this comes from Ted Christ's work, if your data set is very good, that is, if your probes are very good probes, or you're using really solid probes, then the number of data points when you get confident in your level of your trend line begins at around 8 if you're going twice a week. More typically, it's about once per week. You're talking about somewhere around 10. So you need really about 10 data points before you have what would be called a reliable trend. If the data set you're using or the probe set you're using is not as good, it drops drastically to far more probes. And this is research that really has been important for us to understand how many data points make a good trend line for progress monitoring data. Now, having said this, if I'm using my progress monitoring data for something that's not as high stakes a decision as SLD determination, then I could probably get away with far fewer data points. If I'm using it to look at instructional decisions, I might be then using our 4 or 6 data points in a trend to make those kinds of decisions. But when we get to high stakes decisions, this is when the trend line becomes reliable. Another important issue in interpreting progress monitoring is remembering the standard error issue. And that is all measures, every measurement we do has error embedded in it. So the question is, when does change across a data series cross the line from change that could have occurred by chance or accidental change to real change? We know that students' performance in oral reading fluency will vary from one performance point to the next. Maybe we happen to get a passage that was a little easier, a little harder. Maybe we got a passage the student had much more background knowledge about. Maybe the student was physically ill. Or maybe the student just clicked away on the computer. For whatever reason, if one data point to the next data point ended up being very different, how much change will be real change and how much change is accidental change? In CBM, oral reading fluency, Ted Crisp and his colleagues identified that the standard error of measurement for words correct per minute ranges from 5 to 15. So let's work on an average of about 10. So 10 is about the average amount of change that would be within error. So change greater than 10 would be real change, and change less than 10 would be accidental change. So here's a data set. The initial data point is 46, and we're looking at our data after 5 data points. And it looks like we got some real change here, doesn't it? 1, 2, 3, 4, 5 data points. But remember, the standard error is 10. So when we saw a data point here, this change looks like real change, and now we have change from 72 to 90 to 71 to 65. My guess is between 46 and 65, that's real change. Well, let's look at the rest of the data set. Now we continue with our trend line, and we're looking to see, look again, here we have more change going on. This data here doesn't look like real change, and even though there was a big jump here, the trend across this period of time may not have been real change. However, as the data set unfolds, we get towards the end, now we see change all the way out here that probably was substantial from the starting point, but if we look at this change from here to here, it probably was all within basically standard error. Even though it looks like lots of change, it's within standard error. And indeed, if we take a look at the trend line that was produced, it was only 0.08 change across those last 7 days. Another example. Is it real or is it error? Standard error of measurement is 10. And look, at this point here, we see change that might be there, might be real, and indeed it continued that way, and it was reflected in the overall change across the last 7 days of the data series. So I think the point I'm trying to make is that you really need to look carefully at progress monitoring series before you make a determination whether you have real change or change that's an error. One of the things we certainly have known is that guidelines come for decision making. And I shared with you the example from the one school district in guidelines towards making those kinds of decisions. In New York, I know that many schools have developed these decision rules regarding tier movement. And Molly, I'm going to share my screen here again. And I've looked at many of these here, and many of these are excellent. They are excellent examples of how school districts have determined what their decisions are going to be for moving across the tiers. Here's Burton Street decisions. Again, excellent, excellent. Decisions up front and ahead of the before you start a priori. And again, I am just picking these pretty much at random. I actually do not know any of these schools in there at all. Here's another one, and this is a complex decision tree, but a very important one. And again, these are the ways in which we begin to make these decisions about tiered progress and how one is moving across the tiers, and they represent essentially really, really solid ways of making database decision-making processes. Let me return back to the PowerPoint. So, the mantra that I've been saying all along for week after week is, as you know, is without data, it's only an opinion. I hope today I'm going to get to some questions here, and I'm going to start answering some questions, but I hope I've been giving you some interesting ways of looking at these data, doing a gap analysis, calculating rate of improvement, and doing things with the data that can quantitatively give you very, very strong ways that you can begin the processes of moving yourself towards using the data in effective strategies that move towards SLD determination and give us quantitative values for really understanding what's going on with the data. Let me start with the first question here that I have. And I know Trish had a question in a calculation that was done based on last week's cheat sheet, and it was done with kindergarten letter sound fluency, and she came up with a cutting score of -3, which obviously wouldn't be valid. I know how that happens, and it happens because you're working at a very low level where you're expected lots and lots of change at that level. I would refrain a little bit from using those kinds of, using the cheat sheet for making group goals with those kindergarten letter fluency measures and measures that only go for a half a year, because those measures that only go for that period of time are going to be susceptible to really wide variations. I think for those measures, you can pretty much do the strategy of saying, can we move 50% of our kids from the some risk level to the low risk levels? Can we move 75% of our kids, and to set those goals that way? So I think there are some modification, if you will, at that level. So let me see some other questions. There was another question about what the word strategic level meant in step 5 on last week's cheat sheet. Strategic level meant those students at the some risk level. It doesn't mean all the students who do not meet benchmark, just the students that are identified as below the benchmark. I assume they're progress monitored, but it's all students who are below benchmark. It would be Trish, if you're not progress monitoring all those students, it would still be those students below the benchmark. So. Trish asked a very interesting question here. Trish, you asked a question about calculating for winter benchmarks rather than fall to winter instead of fall to spring. You can do and do this on a 36-week basis or an 18-week basis if you go fall to winter, if you want to calculate that process. I think that you can get a fall to winter ROI, and you can put that in step 1 if you want. You can certainly do it that way. It's a different strategy than what I showed you last week. It's doing half-year rate of improvement and half-year goals, and one can do that. Trish, if you want to email me directly about this, I'd be more than happy to work you through the process offline and help you through that. Elaine, slide 22. Let me go back to that slide. Explain the difference between catch-up growth and actual growth. Let me go back to slide 22. I'll be happy to do that. Let me get to that slide. Okay, right here. Sure. Okay. Let's talk about catch-up growth. And I think the way to illustrate catch-up growth is to do it graphically. Let me go to a graphic here and illustrate catch-up growth first. So the catch-up growth is the amount of growth that that student needs to achieve between where they're starting and to get and close the gap to target. So the amount of growth that a student would need to make, the catch-up growth, is the amount of growth a student needs to go from, called target ROI, from where they are to the benchmark. That's target growth, target benchmark, target ROI, also known as catch-up growth. The amount of growth that a student would need to do in order to catch up to their peers over the course of that year. Actual growth is what the student really achieves. So this is what the student really did. This is what they attained. So their attained level of or rate of improvement was nowhere near what they would need to have done to catch up and close the gap. And in fact, the gap got wider in this particular student. So that's the difference between what I'm calling catch-up growth and actual growth. I hope that makes you apply it. Dean asked a question about how can this be applied to the high school level. Dean, I think at the secondary level, the high school level, we have a different kind of scenario. If a student at the high school level and they're performing at levels that are substantially below what would be expected, we would indeed be able to use these same kind of calculations. But when you're talking about secondary level, you're talking about a different set of metrics, because these kinds of measures, the CBM reading measure like this, doesn't really work very well for the high school level at all. At the high school level, I might be using something like a computer adapted test, like a STAR assessment or the iReady measure that I learned about. Those measures, as long as they have a value that you could find for the level of performance that would be at the start of the year and at the end of the year for that measure, it might be a scaled score or a standard score, then these kind of calculations can work. The thing is, at the high school level, we introduce ourselves to an entirely new and different kind of set of metrics and a different kind of decision-making process that I sure hope is carefully considered when one is working at that level. And I think one of the things you might want to be looking for, if you're not getting any kind of professional development on this, is to look for a specific webinar or some kind of presentation on secondary level decisions related to RTI. It's a very different kind of process than we have here with elementary. Rosemary asked a good question. Okay. Well, Rosemary, you're asking the question about a student who can read the text but not move forward on comprehension, and I absolutely 100% agree with you. You can't move the student forward in reading if their comprehension is not moving forward as well. And that's a different metric, and that's a different kind of process than what you're seeing here. This is only measuring one aspect of the reading performance, and this would be something that factors into how well a student is doing against the typical performing student. If I was sitting with a team and we had a measure of reading comprehension, I would hope our reading specialists and our reading folks would be able to talk about where their reading performance falls against what's expected of typical performing students at that grade level. Now that may show up in levels of graded text. It may show up in a DRA. It may show up in all kinds of other kinds of measures that are being taken to address the comprehension question, but that's factored in together. But you're absolutely right. If a student is only reading the text and not understanding, one wouldn't certainly move them forward. I don't see any other questions popping up yet, but I'm going to wait a few minutes to see if anybody else has additional questions they would like to ask before I wrap up today's webinar. I know there were more complex issues today than we've had in others, but I hope I was able to take you through this process simply and in a way that becomes valuable for your own work. I will say that the questions that are being asked about secondary and about additional metrics, additional measures, are very, very important. One never makes any decision in this process on a single metric. I don't care what metric it is. No single metric ever tells us all the story there is about a student. And that would mean that the comprehension metric alone doesn't tell us the whole story either. But together, these metrics converge and help us understand and tell us more about the student's problem and allow us to make much better, more data-informed decisions. As I said at the beginning, I hope the folks who were doing the iReady group are on today because I think you got a good measure. I looked it up. It looks like a great opportunity. I discovered just today a couple of school districts here in my own state that are using it. So if you're using iReady, you can do lots of these same kind of things that I'm doing here. One of the interesting things about the gap analysis, let me say, that's particularly important, is it's not dependent on the metric because what you're doing is you're calculating the ratio of the expected performance to attained performance. So it's the ratio of difference that becomes critical here. So it doesn't really matter what the value is that you plug in there. It doesn't matter whether you're using a measure that has a particular scaled score that they like to use for that particular tool. It will work because you're talking about the ratio between expected and attained. And that ratio is what represents the gap between where a student should be and where they are. I haven't seen any additional questions pop up in the last few minutes. So with that, I'm going to turn this back over to Molly and wrap up today's webinar. I thank you all very much for participating. The next webinar will be in January. I wish you all good health in the new year. Have a wonderful, wonderful holiday break. And keep coming with questions.